alcohol, phenols, and ethers. So basically, I have divided this topic into two parts. That is, this part I will be including a part one. Part one, we are learning about alcohols and phenols, and part two, I will be discussing about the ethers. Part two, I will be discussing about ethers. Now, how the lecture will go? Lecture flow will be this way. So first, we are going to learn about alcohols, phenols, nomenclature. We'll do how to name the compound. Nomenclature is very important. Then second, I'll discuss about the preparation method. Okay, preparations of alcohols. Third method, we'll be doing the properties of alcohols, phenols, and ethers. So all these things we are going to do in a most systematic and good sequence. We'll do and we'll do it from the scratch. Okay, we'll do concept by concept from the scratch so that your understanding of the organic chemistry um, increases. You develop a l- you develop lot of interest in organic chemistry. That is what is my whole point over here. It is nothing like okay, this competitive exam, that competitive exam. If you are aiming, yes, it will help. Okay, if you already know these concepts, then there is no point in watching these videos. So this is for the beginner who find that organic is very tough. So I'll make this organic chemistry very simple. So first thing I am going to discuss is about the nomenclature. Nomenclature. Let's take this example. How to name this compound? CH3. This is okay. I'll put OH over here, and this is CH3. Right. This is the alcohol. How to name this? See, any IUPAC name, IUPAC name has uh, following sequence. There is something called as a prefix, right? First, we write a prefix to be very safe. A prefix, then it is a word root, then primary suffix plus secondary suffix. Okay, next is secondary suffix. It should be in that order. Now, prefix, what does a prefix tells about? Prefix tells about the substituents. Means it is going to tell about these things. These are the substituents. OH is not a substituent, it is a functional group. Word root is going to tell about the number of the carbons on a parent chain. If there are four carbons on a parent chain, then word root will be just but. If there are five carbons on a parent chain, it will be a pent. If there are six carbon, it will be hex, right? It is that way. And primary suffix will tell about a position of the double bond or the triple bond, right? Or if there is no carbon-carbon double bond, it is just single, then we will just write this to be A N E. If there is a double bond, we'll write E N E with the position where it is there. Then if it is a triple bond, then Y N E. Okay, and secondary suffix tells about a functional group. Secondary suffix will tell about a functional group. So here, first thing is that we should know the numbering, how to do the numbering. Identify the longest chain is one thing, and second, we should know the numbering. If you see in this compound, if you see in this compound, there is a functional group. There is a functional group. If you see, there is a functional group, right? There is double bond. There is double bond and there is a substituent also. How to do the numbering? How to do numbering? So priority to give the lowest number. We should be giving lowest number to something, right? Priority to give lowest number is this. A functional group should get a lowest number. then double bond, then there is third is triple bond also. I'll include this triple bond over here. And last is fourth is substituent. Means what is the meaning of this? If there is a functional group, you should give a priority that functional group should get the lowest number. If there is no functional group, only double bond and a substituents, then you should give lowest number to a double bond. If there is a double bond and a triple bond, you should give lowest number to a double bond. If there is a triple bond and a substituent, you should give lowest number to triple bond. If there are only substituent, there are no functional group. This is I'm talking in general. Only substituents, then you should give a lowest number to the substituent, and then all those rules, lowest set of locant, that will apply. So from here, the numbering will start from this side because here is our functional group, and our numbering should start from here. So that 1, 2, it get a lowest number, 3, 4, 5. So what does the prefix include? Prefix is including about a substituents. So over here, what is a prefix? Prefix is a methyl. What position? It is 2 methyl. What is the word root? There are 5 carbons on a parent chain. So word root is pent. Then there are a double bond, means I'm going to include a primary suffix. So it is on a third position. So it is 3 ene. Replace last e of the primary suffix with a functional group. At what position is the alcohol? OH group. It is on a second position. So I'm going to include this to be 2OL. This is how you do the nomenclature. So this is a name of the above compound. We'll take one more example. We'll take this. So this is the compound, and we have to identify the prefix, word root, primary suffix, and a secondary suffix. If you see, there are two substituents. This is the parent chain, right? This is the parent chain, and these are the two substituents. So what would be a prefixes over here? There will be a two prefixes. And what is this? This is a functional group. So prefix over here, a numbering. How to do the numbering? Numbering will be starting from this side so that OH get a lowest number. So 1, 2, 3, 4, 5, and 6. So there are two substituents. One is ethyl. This the name of this is ethyl, and name of this is methyl. There are two substituents. So E comes first in alphabetical order. So I am going to write that first. So name of this compound will be 3-ethyl, 5-methyl. And what is the word root? Word root will be a hex because there are 6 carbons on a parent chain. Where is the double bond? Third position. So 3 E. And last E of the functional group, you replace last E of the primary suffix, you replace with a you replace that with a functional group. What position is the alcohol over here? On second position, there is alcohol. So 2 all. This is how the naming could be done. So this was the nomenclature part. Let's go ahead with the classification. The classification is also important. I'll write over here heading classification of alcohols. First we'll do with the alcohols, how they are classified. So first is compounds compounds containing sp3 carbon OH bond, right? So this is the thing. We are going to discuss over here what is the meaning of primary alcohol, then what is secondary alcohol, and a tertiary alcohol. How it is represented. Always remember that we represent it this way. A primary alcohol, if I want to represent, then I will represent it this way. RCH2OH. Like here, sp3 hybridized carbon. sp3 hybridized means a carbon which is having all the carbon-carbon single bonds connected. Okay, so this is the carbon to which OH is connected, and this is the R group. Now, what is the meaning of R group? R group means it is like this. It could be a methyl group, like this is connecting bond. It could be a ethyl group, C2H5. C2H5 means it will look this way. It could be a propyl group, and so on. Or it could be any branch compound also. Means over here, if I write CH3, CH2, OH, right? This is an example of the primary alcohol. This is an example of a primary alcohol because this is the OH, this is the OH, it is connected to a carbon which is further connected to only one carbon, right? It is further connected to just one carbon. This is what the primary alcohol is. I can take one more example. I can replace this R group, I can put this R group as this OH. So here, functional group is connected to a carbon, although this is a ethyl group, but this compound, this carbon is connected to only one carbon. So therefore, this is still a primary alcohol, right? So this is my R group over here. This is a R group over here. This is primary alcohol. Next is secondary alcohol. Next is secondary alcohol. Secondary alcohol is this. OH is connected to a carbon, which is further connected to two other groups like this. Both the R and R dash may be same or may not be same, doesn't matter, but this is an example of the secondary alcohol. Means examples could be this way. Carbon, right? Examples are this. So over here, this is OH, this is the functional group which is connected to this carbon, and this is further connected to one and two carbon. So that's why this is secondary alcohol. Now both the R groups may be same or may not be same. I can write it this way also. CH3, CH2, CH2, CH3, OH, and a hydrogen. This is also an example of a secondary alcohol. Means OH is connected over here, and this is connected to this carbon. It is further connected to just two carbons. Direct connection. I mean, means over here, what is my R? This is my R, and this is another R. This is what the secondary alcohol is. Then next is this is tertiary alcohol. Next is tertiary alcohol. Tertiary alcohol is represented this way. It is this way. Means three alkyl groups which may be same or may not be same. I'll just show you one example where it is same. CH3, this is CH3, CH3, and OH. So this is OH connected to this carbon, and it is further connected to three carbons. This is tertiary. Again, these alkyl groups may be same or may not be same. So this is the whole classification of a primary, secondary, and a tertiary alcohol. So what happens, in organic chemistry, it is a process. You have to learn the things step by step. Okay, so we should know the terminologies, which what we call as a vocabulary of the subject. Like, you will understand this further if you know what is exactly a primary alcohol, secondary alcohol, or a tertiary alcohol. If this is clear, then you will understand a further part. Okay, so this is knowing one things, small things. That is also very important. Now, I had mentioned I have mentioned about this sp3 carbon. What is the meaning of this? How to identify sp3, sp2, and sp carbon? It is very simple. Okay, how to identify that sp? You don't have to do a valence bond theory for that. How to identify a sp3 carbon, sp2 carbon in a given compound? I'll just tell you the trick. If I write this structure, if this is the compound which we are having, and okay, this is the compound. So I'll label them as this as my A, this as a carbon A, this as carbon B, this is carbon C. I'm just doing the labeling. This is E and this is E, right? So what is a hybridization? The hybridization of this carbon is sp3. Hybridization of this carbon is sp2. Hybridization of this carbon is sp2. Hybridization of this carbon is sp and hybridization of this carbon is also sp. How to identify that? See, if you open up this structure, if you open up this structure, it is this way. On this carbon, there is no any double bond connected. So all are single bond, right? On this carbon, there is one double bond, right? And on this carbon, there is one triple bond, right? So it is very simple to identify. How to identify? sp3 means all single bond connected, single bond connected, we can say. Okay. sp2 means at least or a double bond, presence of a double bond, presence of double bond. And sp means a presence of triple bond. This is what the sp is, right? So this was my atom A, carbon A, this was B, this was C, this is D, and this is E. So this is how we understand. And if we go to a previous example, if you see over here, these structures, this was sp3 carbon, right? This was sp3. All these carbons were sp3. Yes. So we were understanding the classification of the compounds containing sp3 carbon OH bond. So this is sp3 carbon OH bond. So here this is primary, secondary, and tertiary is done. Next, we'll talk about the under this category allelic alcohol. Second, under sp3 carbon OH bond, that was primary, secondary was A. Just label that as a primary, secondary, tertiary, and this is allelic alcohol. Allelic alcohol means hydroxyl group. Hydroxyl group is attached. I'll write a thing. Hydroxyl group is attached to a sp2 carbon, to a sp3 carbon, to a sp3 carbon next to the carbon carbon double bond, next to a carbon carbon double bond. Means I'm talking of this alcohol. CH3, CH, double bond, CH2, OH. I'll just show one example. This is a allelic alcohol. Here, OH is connected to this carbon, which is sp3. And next carbon is what? Next carbon is sp2. So this is an example of allelic alcohol. I can show more. A bond line structure. In a bond line structure, I can show this. This is also an example of a allelic alcohol. Means what is the meaning of this carbon carbon double bond is there? This is how we write now. Hydrogen. Here there are two hydrogen. In bond line structure, we don't show this. So this is what it means. It is connected to what? sp3 carbon, and what is this? This is sp2. So next to sp3, there is xp2, and this is what the allylic alcohol is. Next is benzylic alcohol. Next is benzylic alcohol. Means benzylic alcohol, in this alcohol is this way. You take a benzene and this is CH2OH. See, OH is not directly connected to a benzene ring. If OH gets directly connected to benzene, it becomes phenol. Okay, it will fall under a other category. I'll talk that later. So this is a benzylic alcohol. This is an example of the benzylic alcohol. Over here, this is a primary benzylic alcohol. Primary benzylic alcohol. Uh, Secondary will also exist. Secondary means this is the carbon, this is OH, this is H, and this is R group. Means it is connected to one carbon, two carbon. One is this carbon, another is this carbon. Means it will be a methyl group. No, so this is secondary benzylic alcohol. Benzylic alcohol, and this is not a phenol. It is not coming under the category of phenol. It is a still alcohol only. It will show the chemical properties of the alcohol only. Next is I can show a tertiary this way. R dash and a OH. This is tertiary benzylic alcohol, right? So it is benzylic. Why? It is connected to OH and it is further connected to a benzene. But you can see that nature is same. Here also the this carbon is sp3 and this carbon is sp2, right? So that's it. Next is compounds containing, right? Category 2, that is compounds containing sp2 carbon OH bond. Okay, this is called as a vinylic alcohol. Vinylic alcohol. It is a kind of unstable, but I'll just tell you, um, not very stable vinylic alcohol. It is, let's take this CH3, CH, C double bond, and OH. This is an example of vinylic alcohol. Here OH is directly connected to what? Here OH is directly connected to sp2 hybrid carbon. Okay. And what if it is connected to a benzene, then will it be a vinylic alcohol? Will it fall into that category? Means if it is, when we talk about this OH connected to this carbon, is it vinylic? We call this to be a new category. It is called as a phenol. It is no more a alcohol. It is a new category. It is a alcohol. It is a phenol, right? So this was the classification. This was the classification of the vinylic, allelic, and the benzylic, and we learned about what is the meaning of primary, secondary, and tertiary. So see you in the next class. That is, we'll learn about the preparation methods of the alcohols and phenols. Thank you.